Good morning, everyone, and thank you so much for joining our March Town Hall for IGSHPA. My name is Courtney Lull. I am the chairperson for the IGSHPA Board of Directors, and I will be your moderator for today. So we're going to go through just some IGSHPA news, stuff happening with the organization right now. As a reminder, if you have any abstracts that you would like to submit for town halls or dig deepers, you can do so on our website. You can go to events training and then use this form right here to submit an abstract for a town hall or a dig deeper. We also offer sponsorship opportunities for our town halls and dig deepers. If you're interested in taking a look at that, right below the ability to submit an abstract is another link that will allow you to look at town hall and dig deeper sponsorships. Which then leads into talking about our 2023 conference. Registration is now live. We are again with National Groundwater in Las Vegas this year. So if you go to our website, IGSHPA.org, there's more information and the ability to register. If you are exhibiting or interested in exhibiting in a booth this year, those opportunities are available as well. Just again, go to our website and you will find information for exhibitors. And then sponsorship and advertising opportunities will also be online within the next 2 weeks. If you have any questions about dig deepers or town halls or our conference, you can always send an email to info@igshpa.org and we will answer any questions we can. Something new on our website is the business directory. It has been revamped, so now you can actually go through a map of the United States and Canada and pick on a state or province and be able to dial down and take a look at anyone that you might be looking for within the industry. You can use any of these keywords or sections to type in some keywords to search for whomever you're looking for. And then this is what the business directory listing will look like. If your business is listed in the business directory and there are any changes that you would like to see made, there is a form that you can fill out on the business directory homepage and just send that in to info@igshpa.org and we will get that updated for you. As a reminder, CEUs renewals are required as part of your renewal process. Town halls, dig deepers, and the annual conference do qualify for CEUs. Just as an important note for today, if you would like CEUs for this town hall, please send a chat message while on this Zoom to the IGSHPA account directly, and please include your name and email. Just a few housekeeping for today before we get started with Matt. Please use the chat for any speaker questions. I will moderate and ask those questions at the end of the presentation. If you have any specific questions, just list them there and we'll get as many of them answered as we can. If there are any remaining questions at the end of the presentation or the end of our time today, we will try and answer those as best we can through email later. Please make sure that your microphone is muted through the entire presentation, and we will have a recording up for this later. And just a quick disclaimer, the upcoming presentation represents the opinion of the presenter and does not represent any official position, opinion, or endorsement of any products or services by IGSHPA or its members. IGSHPA town halls and dig deeper webinars are for member updates and education on the latest information in the geothermal heat pump industry and are not meant to endorse one technology brand over another. It is the presenter's responsibility to disclose any conflict of interest or position that may arise in the content of this webinar. And with that, I will stop sharing and introduce our speaker. Matt Tokarik is a professional engineer who works with Subterra Renewables, a renewable energy developer who designs, builds, owns, and operates geothermal heating and cooling systems across North America, with the goal of significantly reducing greenhouse gas emissions and ultimately reaching net zero building operation. Previously, he has worked with design firms to develop strategies for building energy and carbon emission reduction for new and existing buildings. Matthew's a seasonal instructor at Ryerson University and sits on Canada's GBC's Zero Carbon Building Standards Steering Committee. And with that, I will turn it over to Matt.
Thanks, Courtney. Pleasure to see everybody here today. I'm just going to grab the screen, I guess. So let me know if I've done that. Okay, so you should see now my screen. Okay, we're good to go?
Yep, we see your screen.
Okay, right on. So I'll get started. thanks for the introduction, Courtney. Just to add a little bit more, I guess, to that, like Courtney said, I'm an engineer by training. Most of my experience and work has been in the energy efficiency field, carbon efficiency, building science, building design. I'll caveat this by saying that I'm not a driller, so any questions that come up hopefully can be related to building design, HVAC design, geothermal design, those types of things. I'm also sitting today in Toronto, so I've got a bit of a Canadian point of view. So we don't get into too much technical. I can certainly speak Fahrenheit, but if there's any Canadian references, that's the reason why. I've been with Subterra for 5 years since its inception, and like Courtney said, have been very much steeped in the world of low carbon buildings and building design, both professionally and academically over my career. So just to give the next introduction briefly here to Subterra, because we'll be speaking about it today. Subterra is a geothermal utility company. Again, we're based in Toronto, but service the entire North American continent. We're vertically integrated as well, so we've got drilling in-house to do the actual delivery of the utility projects. A lot of this should become much more clear in terms of what we're doing here when we talk about utility and energy as a service, which is part of the topic for today. And any questions that you still have that are unclear, please feel free to bring up. So in terms of the agenda today, there's 3 major topics I'd like to cover. The first is just a bit of a context. Really, why are we talking about this stuff today? Again, from my point of view, where we stand, geothermal is one of the best ways to get to net zero in the building sector, which should not be news to this group, but we'll just dissect that a little bit more in terms of what that means from my point of view. Number 2 is a discussion around the financial benefits of geothermal. A lot of what we talk about is how to get these systems installed and how to give owners of buildings or developers the benefits of the financial system. So again, this is not necessarily all of the technical aspects or the drilling aspects that a lot of folks talk about, but more specifically, what are the financial benefits that we can talk about? And then third, a very specific discussion about the energy as a service or utility model itself, how it works, what are the benefits, and how you can think about this in your projects. I'm going to try to talk for about 30 minutes. I recognize we are at 11:40, so hopefully around 30 minutes will give us about 20 minutes of conversation. I always prefer to try to have some back and forth and answer questions as opposed to just speaking into the screen. So I'll try to get through this in around 30, and then we can have a little bit of time left over at the end for conversation. Okay, so the first thing to talk about again is what are we doing? Why are we talking about this? How are we getting our buildings to net zero? So when we're talking about net zero and emissions, we were really talking about the fact that human and man-made emissions have a large impact on our globe. Everybody's heard about the climate crisis and the fact that the surface of the Earth is warming by a few degrees, which many folks have said, why is that such a big deal? And without getting too in depth as to the specifics of the climate crisis, I think everybody here should know that we're starting to see more and more severe weather events, floods, droughts, fires, extreme highs in temperatures, et cetera, that are causing significant impact to human life and to economic impacts, et cetera. So what we're really trying to do here is address our carbon emissions, and amongst the inventory of carbon emissions, a big portion of that is the buildings, which is again what this group is largely focused on. The World Economic Forum has stated that buildings are one of the major pieces of the equation to get to net zero and ultimately meet our emissions targets by 2030 and by 2050. So as we zoom in, I just want to talk about what that really means from a building standpoint. You can go on the City of New York carbon inventory, emissions inventory for a given year, what you'll find is that the breakdown looks something like this, and this is fairly common across most large cities. Toronto has a very similar breakdown, and most large cities have a similar breakdown as well, where north of 60% of the carbon emissions are associated with buildings. So a really, really significant portion that needs to be addressed and needs to be reduced through building design, fuel switching, electrification, those types of things. As we zoom into that 66% in this case of carbon emissions in a building, we're really talking about heating systems for space heating and for domestic hot water use. Of that 66%, we're usually talking in the neighborhood of 75 to 90% of carbon emissions coming from that building sector associated with, again, space heating, hot water heating, et cetera. So on the global context of what we're trying to do here in terms of talking about carbon reduction, as we focus more and more narrowly here and get into our conversation about geothermal, which is of course the topic for today, that is really what we're trying to tackle, is this large piece of greenhouse gas emissions in the building sector. That again is a very large portion of the general emissions, particularly within cities. So again, as we think about how we get to net zero and how we reduce these emissions, we have to start thinking about building design, of course. So this is sort of the formula. This is a bit of a cheat sheet, if you will, of how we get our buildings to net zero. This is not a secret, by the way. There's nothing proprietary. There's no secret technology that we're waiting for. We can absolutely get our buildings to zero emissions, and we know how to do it. And this is how. Before I dive into it, I'll just say that most of the time when you hear somebody talk about a net zero or a net zero carbon building, the first thing that comes to their mind is plastering a building with photovoltaics. That is part of the puzzle, but that's usually the last piece. So if we just work our way through this triangle, we'll talk about the order of operations to get there. And so if photovoltaics are the last thing that we think about, what's the first thing? The first thing that we need to do is talk about building loads. So these are actually passive designs. They don't have anything to do with the HVAC system other than the impact that they have towards it. But this is things like improving our insulation, putting better glazing into our buildings, reducing thermal bridges, orienting properly to the sun, using the right window to wall ratio, shading properly. All of those sort of things go into first setting the loads for the building. Of course, these loads again inform our HVAC system design and how many loops we're going to drill into the ground. But that's the first step. So once we reduce our load, then we can start thinking about putting the right mechanical system into that building. So step two, after we've reduced those loads, we're then going to go in and select the right HVAC system and the right active systems like lighting and plug loads and all of those sort of things. So this is where we really start to get into the conversation about selecting geothermal systems. And particularly important is fuel switching. So what we're doing by using a geothermal system and adopting a heat pump technology is moving from a fossil fuel-based combustion system, which is driving all of those carbon emissions, to an electric-based system, which ideally, if your grid is clean, and that comes with an asterisk depending on which part of the country you are living in, but that is the building side way that we get to a very low emissions. And then finally, once we've done those things correctly, then we can start thinking about generation. And ideally, again, when you've got an all-electric building, now it makes a lot more sense to put photovoltaics on your building to actually service that electric-based system. A couple metrics here on the left-hand side, just to speak to and define in case we decide to use them again through the presentation. Number one is a fairly new term in the energy community called TEDI, thermal energy demand intensity. The other way to think about this is your annual heating demand. So again, this is all due to or all related to your passive design features, insulation, glazing, et cetera. The second one is total energy use intensity. This is when you start thinking about how much energy, that could be natural gas, electricity, et cetera, are your active systems using, so your HVAC system, your lighting, your plug loads, et cetera. And then greenhouse gas intensity is of that energy use intensity based on the type of fuel that is being consumed. You can calculate how many associated greenhouse gas grams or kilograms of CO2 are being emitted. Everybody here should know the basics of the geothermal system, but we like to show this slide just to describe at a high level the fact that we're using the earth to generate and reject heat into as a thermal battery. So again, as we're thinking about these net zero emissions, I just want to pause one more time and reiterate the fact that what we're doing is removing our primarily fossil-based systems and replacing it with electric-based systems. The reason we can get so much efficiency, and we like to talk about numbers, reduction numbers of carbon emissions in the 75 to 90% reduction range is twofold. Number one, and I'll bring these terms back, number one is a focus on energy use intensity. So after we've reduced our loads and we can start thinking about our mechanical systems, which are the energy consumers in our buildings, we can start talking about the fact that heat pump-based systems are extremely energy efficient. So when you think about your typical boiler or furnace, you can think about an efficiency that's somewhere in the range of 85, 95%. When we're talking about a heat pump and you hear the word COP, another way to think about that is efficiency, system efficiency. And when you hear a COP of 4, for example, another way to describe that is an efficiency of 400. And so when we're going from an efficiency of a boiler at 90% up to an efficiency of a ground source heat pump to 400%, we've got a really, really big jump in energy efficiency, which translates into a drastic reduction in energy consumption in the building. So that's how we get to that low energy use intensity. The second piece of that, and this is where we really get a 1-2 punch with a heat pump-based system, a geothermal system, is when we fuel switch. So not only are we taking that step from 90% efficiency to 400% efficiency, when we fuel switch, we are using a different emissions factor. And I'll just pause to describe that emissions factor for a moment. This is the associated amount of CO2 emission with a given unit of energy. So for every kilowatt hour, or for every joule, or for every pound of steam, for example, for every unit of energy, there's an associated gram or kilogram or ton or pound, however you want to describe your metrics, of associated energy. Fossil fuel-based systems, so that's a natural gas boiler or furnace on your site, have a really, really high emissions factor. I'll just speak to Ontario because I know these numbers fairly intimately. If you're burning natural gas on your site, and again, this is a metric unit, but you're around 200 grams per kilowatt hour of energy consumed. If you switch to electricity, you are around 40 grams per kilowatt hour of energy consumed. So units aside, there's a split, a delta of roughly 4 times, 4 to 8 times, I guess, in that example, of 40 to 200. So a really, really, really large jump. And I'm just thinking of the math off the top of my head, so forgive me if the numbers are off. But once we fuel switch, again, after we've already increased that energy efficiency, we get our second piece of that puzzle, which is a reduction in carbon emissions, and that's how we're generating these really, really massive carbon reductions. So that's why I believe we're here, why we're talking about geothermal exchange systems, and why they're so beneficial to our net zero solution. But why else are we doing this? Obviously, I think something that the industry as a whole has been challenged with is making this work from a financial standpoint, and that's something that we again talk a lot about in our organization. How do we remove the financial barriers, and how do we provide financial benefits to these systems such that we can install them, get them in all of our buildings, and impact the carbon story. So there are lots of financial benefits. The way that I like to sort of set the stage on the financial discussion is around two terms. The first is capital expenditure or CapEx, and the second is operating expense or OpEx. Generally, what we tend to find is that geothermal systems are higher in terms of capital expense, CapEx, right? And the reason being is that drilling, as everybody probably knows in this room, is expensive, and it tends to be more expensive than the competing HVAC system. And when we're talking about the competing HVAC system, we're typically talking about the plant system. That's the term that we use to describe the stuff that's creating the hot and the cold. So that tends to be our package of boilers, chillers, and cooling towers. So what we end up doing with the geosystem typically, and to state it very simply, is we remove those components, and instead we drill into the ground and put a heat pump based system in and make that plant equipment replaced by the geothermal loops. And generally, again, the CapEx tends to be about 1.5 to 1.75 times more than the competing HVAC system. So higher CapEx. However, because we've removed all of those pieces of equipment, right? These are our operating pieces of machinery. There's moving parts, they break down, they need repair, etc. A geosystem actually tends to be much less to operate. So our OpEx is less. So higher CapEx, lower OpEx. And that's because of a few things. One we've already discussed is the energy savings. So we're paying less in utilities by removing a cooling tower, particularly, which works on evaporation. You need to add more water to it and add chemicals to it. We've reduced some of those consumables. And then the big thing that a lot of folks don't generally think about, but is a very large benefit, is the reserve repair and maintenance. So again, when we're moving these big pieces of equipment with moving parts, chillers, boilers, cooling towers, etc., we are removing a lot of the service and maintenance required, and of course the capital reserve that you have to then pay in 15 or 20 years to replace, because we all know that these geothermal loops are going to be in the ground for much longer. And really, the system simplifies down to the geothermal loops in the ground and a couple pumps to do the circulation. So all of that is stated and reiterated is high CapEx, low OpEx. So then where are all these benefits if we're going to pay more? Well, there's savings that we're going to talk about here, but the other way to think about this, or another benefit that we can think about, is if you put on your real estate hat. And so obviously when we're designing these systems and we're installing these systems, we are talking to the real estate folks and the business people who are making these design decisions. And so one of the big advantages that we always like to talk about, of course, is the additional roof space. So when we are designing these buildings and the HVAC designers are designing these buildings, again, they're removing those pieces of equipment, the boilers, the chillers, the cooling towers, from what's typically on the penthouse level, so roof space, some of the best real estate, right, the top floor. And in turn, we're adding a little bit of space in the P1, P2 level for a pump room. And this is where we put the manifold, plate and frame heat exchanger, circulating pumps. Generally, we find that this room can be around 400 or 500 square feet, and we can usually tuck it into a corner where we don't lose parking, which is something building developers obviously also hate. But the sort of mindset shift here is that we're moving this stuff from the top, we're bringing up space, and we're moving it down into the pump room. The result of which can be quite drastic. Now, we're never going to get rid of our penthouse totally, unfortunately. Just in terms of the way that these buildings are designed, we obviously still need to have makeup air units to do the ventilation. There's often still a backup generator. There's sometimes still domestic hot water systems. So we often can't get rid of the entirety of it, but we can save a lot of space. And when we're talking about space savings, that translates into dollars in the real estate folks' minds. You can do a couple things with that. You can get outdoor amenity spaces, which gives more, enjoyment and value to the building. But generally speaking, we often find that building developers can even get more rentable or saleable space. And if you're a condo developer thinking about saleable space on a penthouse level, you can sell that space for $1,200, $1,500 in downtown Toronto per square foot. So every square foot that you save by reducing that mechanical penthouse can be really, really impactful and really valuable from a dollars and cents standpoint. The next thing to touch upon here is all of the incentives. So I imagine everybody here has had some exposure to the IRA now, which gives a really, really impactful tax credit to the owner of the system, up to 30%. I believe that there's been a specific town hall webinar about the IRA in particular, so I'll point you to that recording as opposed to going through all the details here. But really, really impactful. The other thing I'll mention for anybody who's north of the border in Canada is the impact to carbon tax. So the way that our carbon tax system works in Canada is that you're paying per kilowatt hour, or you're paying at the pump when you're filling up your car or your truck. That tax effectively gets added on to the unit rate that you have to pay to the energy provider. And so right now the carbon tax is $60 per ton, and it's going up to $170 per ton. If you were to sort of calculate that into dollars per kilowatt hour, for example, or dollars per cubic foot of natural gas, the effect is that the cost of natural gas is going to roughly double. So by 2030, our government is planning to move, again, that carbon tax up to $170 per ton, which is going to effectively double the cost that you're paying for natural gas. So really, really impactful from a policy and regulation standpoint to fuel switch. Again, what we're trying to do here is switch out of that natural gas use and into an electric source to gain that carbon tax reduction in that example. Okay, so again, as we're thinking about real estate and the benefits, there's many, and some that we've already talked about here, but one thing that I want to point out, particularly from the folks who are thinking about long-term ownership of the asset. So this is REITs, real estate investment trusts. This could be apartment owners, anybody who is going to own the building for a long term and effectively own the HVAC system can get a really, really impactful value increase from the net operating income increase. So I want to just touch on that for a second. So if you're a building owner with an apartment, for example, that you own, you're collecting rent, so that's your revenue, but you have to pay operating expenses. You have to pay for your utilities, you have to pay for your insurance, you have to pay for the maintenance of the building, the property managers, et cetera. So all of those things are costs that you have to pay. The difference between those two, the revenue that you generate from rent minus your operating expenses, is what we call net operating income. Okay, so NOI. And one of the ways that you can increase your NOI, you can have more income going to your bottom line, is by reducing your expenses. And so one of the ways that we just discussed to reduce our expenses is by building a geothermal system. And so when we have a geothermal system, we reduce our utilities, we reduce our reserves, repairs, maintenance budget. So that reduction in cost results in an increase to our net operating income. We're getting more money to the bottom line. And I want to bring your attention here to this little formula on the bottom right. It's a simple formula, but it's very impactful. The way that real estate asset owners value their buildings is through what we call an income approach. And basically it says that the building value is equivalent to the net operating income. So how much income can you generate from this building, if you think about the building like a business, divided by what's called the cap rate or the capitalization rate. This is sort of varying based on market that you're in and type of building, but it generally tends to be in this range of around 4 to 6%, 4 to 7%, and it fluctuates with the market. If you think about this another way, dividing by 4% is the same as multiplying by 25 times. Dividing by 4%, I'll say this again. Dividing by 4% is the same as multiplying by 25. So what that says, really simply, is that for every extra dollar that you can save, the value of your building is multiplied by 25 times. So that's really, really powerful. So for owners of buildings who have geothermal systems, if they can increase their NOI, and let's say the building is worth $10 million, by increasing that NOI, the value of that building might go up to $11 million or $12 million just because of this NOI savings. So that's really, really impactful, and that's something that really resonates with long-term building owners. As we move and think about a different business model, which is the condo market, these folks are developing these buildings, selling the units and walking away. They're moving to the next project. What's really impactful for them is sales. So what we've found is that there's data that says, given two equivalent buildings, same location, same price, et cetera, those things are obviously important. But given those factors, we're finding that more and more buyers, especially young buyers, are selecting green buildings over conventional buildings. And so what that means is that units are selling faster. And when you're talking to a developer and trying to say, hey, you should put a geothermal system in your building, if they hear I'm going to sell more units faster, that's gonna make them light up. So that's something really, really important and impactful that we like to speak about when we're talking about geothermal systems. And then, of course, with the reduced utility rates and less energy, there's a large hedge against future escalation for owners and tenants in these buildings. I'll just mention one more piece because I think this is really salient. When you're talking to building owners, we've heard recently from some folks who are in the asset and investment space, the REITs. They're really thinking about future proofing, and what they've told us is they've said, hey, we know that geothermal, this is the way that buildings are going. It's not an if, it's a when, and we're starting to think about the future. And the assets that we own now are being designed with geothermal systems, because when we go to sell this building, let's say I'm an apartment owner and I sell my building in 10 years, I know that nobody's going to want to buy it, basically. And conversely, they said in the future, we're not going to buy a building that doesn't have a geothermal system in, because we know as soon as we do buy it, we're going to have to put dollars up to install a geothermal system to, again, bring the operating costs down, avoid carbon tax, get the tax credits, et cetera. So these geosystems, and this is, again, not me, but this is what we've heard from some of these investor types. They're saying that these geothermal systems are just table stakes. This is now becoming the price you have to pay, or the minimum requirement to build when you're starting to think about future proofing. Okay, so the third point to narrow this out is to really talk about how the energy as a service product works. So there's a couple different names for this. We call this the service energy as a service. Of course, we have a product name for it, which we call Aura. We like to get, again, buyers excited and developers excited about putting in, the granite countertops, but also putting in the Aura system, something that's fairly consumer focused. The other way to think about this, though, is a utility model or a DBOOM model, where the acronym stands for design, build, own, operate, and manage. But that's effectively what we're talking about. And so for the next piece here, I'll walk through how this all works and the ins and outs. So really what we're talking about when we're discussing energy as a service is the fact that we partner with developers or building owners to effectively become their heating and cooling utility and act as partner. And it's applicable in many different cases here. So we can do greenfield, retrofit, or district. There's no sort of building that this doesn't work on. We're really generally focused on a large scale. So where a Dandelion, for example, might be doing single families, one-offs, we're generally trying to focus on the broader scale. So kind of think 100,000 square foot or greater, and kind of the bigger the better. We also do acquisitions. So in terms of operating systems that are already operating, we can come in and act as the asset owner, take over the system, bring it up to proper working order if needed, and then continue to operate it. And then the other interesting thing is that we can add complements to this. So this doesn't necessarily have to be only geothermal systems. That's what that's sort of the bread and butter. But there are cases where we can connect this to, for example, a shark system or other wastewater type systems that can speak really nicely with the geothermal system. Other low temperature hydronic systems is another way to describe it, where from an engineering standpoint, they can work together. So again, what's included, I'll discuss in a second, but generally what happens is we enter an agreement with the building developer, the building owner, and we say, okay, we are going to provide these services, again, the design, build, own, operate, and maintain, and all that's governed by a contract. So we enter into usually a 30-year fixed fee contract where we provide the capital upfront to build the system, to install it, and over the 30 years, we receive what's called a renewable energy fee, and that's sort of how we work the contract. So from the developer standpoint, typically what happens is they actually have an improvement on their pro forma. What they're doing is they're trying to put a budget to what this building is going to cost them. Again, their traditional budget would have a boiler, a chiller, a cooling tower. When we enter the conversation in an energy as a service agreement, we say, okay, you're no longer going to have to pay for those pieces of equipment because we are going to pay for the system. We're going to put up the capital to install the geothermal system. So when they might have been carrying $2 million or $1.5 million for all the systems, they actually get to scratch those out. So right away, there's a benefit in their pocket to their pro forma, to their construction budget. And then over the life cycle, there's a savings usually to the end user. So we're always doing the calculation to say, what is this monthly fee going to cost? We build out an energy model to say, here's how much energy we assume this building is going to need. And we sort of understand what the competing conventional system would be. And we always make sure that we're the same. And usually we try to target about 10% less than what the conventional system is going to be. This does not work if we are a cost premium on the operation. So what you end up with is a happy developer who's saved some capital costs up front. And you also end up with a happy tenant who's got some operating savings as well, and again gets to live in the green building. So in terms of actually putting this together, we bring all the pieces to the table. Again, the design, the construction, the actual drilling. We've got a vertically integrated group that has drillers in-house. We're the ones who are taking the risk of owning and operating that system. So we do all the repairs, we do the maintenance, we do the monitoring, and we've got a performance guarantee that says this is going to work and you're going to get your capacity that was designed for. And if not, then we're the ones who need to go and make the repairs or replace the system to make sure that it's operating correctly. So this sort of summarizes that the operating cost comparison. When you look at the left-hand side called baseline, this is again that conventional system, boiler chiller with a fan coil system usually, versus our geothermal system. And so there's I'll say sort of two major buckets that are included in this. So on the left-hand side, you see makeup water, natural gas, electricity. Those are those consumables. Those are the utilities. But again, the full picture is actually by including the other operating costs, which are the maintenance to otherwise maintain those pieces of equipment and the capital reserve. So you know that your chiller is going to break down in 15 or 20 years, and it's going to cost you $1 million to replace that. So over those 15 years, a prudent asset manager is putting away $1 million divided by 15 plus some escalation, so that they don't have to, cough up or find that $1 million. They've already got it saved. So that's those capital reserves. On our side, the geothermal system, you can see the makeup is sort of reduced and blended, but generally what you're seeing is a fee for the heat pump electricity. So the users or the tenants are still paying for their electricity in their suites. This is to run their heat pump, for example, and then they're paying their renewable energy fee, and we've got blended into those our maintenance and OPEX costs, for example. But as we stated at the top of the conversation here, geothermal system is a little bit more expensive on a CapEx standpoint, but from an OPEX, from an operating standpoint, much less. So because of that, we can recover some of our financing costs, and we still can offer a savings to the tenant here. And again, we usually like to target around 10%. This is sort of project specific, but that's generally where we try to land. Okay, so just to walk through a little bit of how the actual project is structured when we're involved, we first start off with a feasibility study. This includes the desktop review, so energy modeling to understand how big we know how big the building is going to be, but how much energy is it going to consume? How much loop length are we going to need to install? What is the cost going to be for that drilling? We'll also go and get on site and do an exploratory test. So we like to figure out what is the exact ground under your building. Obviously, the capital cost of our drilling or of anybody's drilling, as probably most people know here, is largely dependent on the geology and lithology below the building. And so we like to go in and figure out exactly what that is for construction purposes. We also do a thermal conductivity test, again, for engineering input, so that by the time we've completed our feasibility study, we've got a really, really good understanding of what the design is going to be and what the capital requirements are going to be of this system before we move forward. The next stage of this service is to go through the detailed design, but we like to have this pre-feasibility stage prior to that before we fully commit. Just to reiterate, our group uniquely, I would say, is vertically integrated. So that means that we provide this utility service, but we've also got the drilling expertise in-house. This is, of course, really important to us, being the owners of these assets, the geothermal asset for the long term. We like to maintain the quality of the install, but also it can be very difficult, and I'm sure as most people can appreciate, the construction schedule of a building development is a moving target at best, and can be, a nightmare at worst. And so trying to manage that schedule with another schedule of a driller who's trying to play that game with another 5 potential clients can be quite difficult. And so managing that timeline is something that's really, really important to us. And so that's part of, again, the service that we provide. Just to speak a little bit to the specifics of the ownership, all of the contract language that is settled on in we call it a geothermal energy supply agreement. You can sort of think of this as similar to a power purchase agreement, if you've heard that term before, delineates the ownership. And so when we're engaged, we are going to own what we define as the geothermal system, which is really what you've seen or what you can see here in green. So that's the loops in the ground, the lateral piping in the ground, some stuff in the mechanical room, which is largely the plate and frame heat exchanger, the geothermal side pumps, any other chemical feed, expansion tank, et cetera. And then the HVAC side, once you're downstream through the building, that's owned by the building. We have to be very, very clear on this delineation because, of course, we try to avoid as much finger pointing as possible. And if there's a problem, glycol needs to be topped up, something's not working, a pump is broken, it's very important to understand whose responsibility that is to maintain a good relationship with the customer. Again, as we are engaged in this agreement, we've got a responsibility to maintain the system. So again, that's our geothermal system. And this sort of has 2 major components. The first I'll say is kind of the brains of the operation. So we've got sensors on these things monitoring the temperatures and the flows going in and out of the ground. If you put your thermodynamics hat on, you'll know that can measure the total BTUs going in and out of the field. So we're really, of course, concerned with and thoughtful of the balance of the field. And so that's our responsibility. We want to make sure that we know how much energy is going in and out of the field so that we don't have any long-term temperature creep. The other piece of the operation and maintenance program is the boots on the ground. So this is getting guys into the mechanical room to do the maintenance. Largely, most of the time, this is sort of akin to getting your oil changed in your car, getting folks in to make sure that the pumps are running, they've got clean filters, lubricated, electricals are working, all those sort of things. And then the third component of this is 24/7 service. So if one of the pumps goes down, we're the ones who need to send somebody out onto site to make sure that the pumps are running, because of course, if all the pumps go down, then the building could be without heating or cooling. There's generally 2 pumps duty standby, so that's never really an issue, but just to make the point, we're the ones who are responsible to make sure that those are operational. And so, okay, that's sort of the walkthrough there of the service. And so if you are, you know, insofar as you've got a building that's looking at geothermal, this is sort of our criteria to get into a conversation about starting the process. So again, we're typically looking for larger buildings. If you've got one house, we typically don't play in that space. If there's, you know, a group of houses, that's when we start to have a conversation. But generally, we're looking for a large building or a large cluster of buildings. We're seeing more and more neighborhood scale planning and design. And then, you know, just a piece about timing. You've probably heard this a million times, but with any good sustainability project, integrated planning is crucial, and the earlier the better. What that really means for us is usually in and around the schematic design phase, or the zoning is kind of when we like to get involved. Typically, we have to make sure that we've got architectural programming for our mechanical room done, and that happens pretty early in the stage. So we want to make sure that we don't let the building designers get too far down the road and then say, hey, by the way, we need to find 500 square feet in your parking level, because at that point, sometimes they've already allotted that to storage or parking or what have you. So the earlier the better. We like to make sure that the mechanical design team is bought in. They know that the HVAC system is going to be a geothermal complementing system. And so again, the earlier the better. The last piece I'll leave you with here before we open it up to questions is just a note that I know Courtney suggested there's continuing education units available here. We've got a more fulsome version of this presentation online at AEC Daily, and there's other accredited learning units or education units available. So if you wanted to go to that website, you can watch a similar and more lengthy presentation and get credits for your particular field or group. And with that, I will say thank you and open it up to questions.
Great, thank you so much. So one question we have is, for building value increasing using operating costs, is the energy savings and building value for the life of the building, or what is the length of time for that?
It's sort of a snapshot in time. So I'll just go to this. So what we're talking about is how does this formula work, and when does it take effect, right? So if Courtney, if I were going to sell you a building today, I would say over the last maybe 6 months or a year, you would sort of select a sample. Here's how much it's cost me to operate this thing. And you say, okay, great, Matt, I'll pay you this much for it. And that's the price. So it's sort of a snapshot in time. The other way to think about this is that there's folks whose whole business is purchasing real estate and increasing the value by improving NOI. So again, Courtney, you could buy this building from me and you could go, Matt, I know you're doing a terrible job of operating this thing. I know the rents are too low, and I know you've got a poor, mechanical system and you're spending too much. So you could actually buy that, given for example, maybe trailing 12-month operating costs, and you can say, I'm going to go and I'm going to increase the rent, and I'm going to reduce my utilities, i.e. maybe I put in a geothermal system or do some other things. And if you can create a bigger spread, if you can create the NOI, then you get that value increase. And then if in 10 years you've done a really good job at increasing that NOI, you can sell it for the increased value. And that's kind of the game that a lot of real estate investors play, is an increase in NOI.
Great. So when talking about energy as a service, generally, what is the term of the contract?
It's typically a 30-year term.
Okay. And is that fixed for the 30 years, or do you generally have just a $1 buyout at the end, or is there something a little bit different depending on the project?
So, right. So at the end of the 30 years, the system is turned over. The effective value becomes $1. So you've paid off the tenants or the condo board or the owner, whoever's on the other side of that, has paid off the system. The system is turned over for nominal value, and they own it. And usually, just to speak to that, part of the reason that 30 is an interesting number is that we like to hand it over with good useful life left. And so we are, again, we're trying to be prudent asset managers. And so we're thinking about the length of the equipment. So if you think about the length of a hydronic pump or a heat exchanger or what have you being in that maybe 20, 25 year mark, you can go look at your ASHRAE book to see what the guidance says, but it's usually in that range. We're reserving for those parts, and usually you can assume that before those 30 years, we've replaced those parts. So you're actually getting a system with loops in the ground that, of course, are not going anywhere, not degrading, and usually something with a pump set that's maybe 5 or 10 years old that still has a lot of useful life. So the intent is that the building owner or the condo or whoever is on the other side of that is receiving a system that becomes theirs and is in good working order, so that they don't have to go replace the whole HVAC system at the end of the term.
So someone made the comment that with the new credit, they're seeing that these systems really aren't a premium cost anymore. And I know between the US and Canada, there's quite a few incentives. So are you seeing that there's more of a level set in the actual installation cost? So how does that affect your model?
Yeah, so absolutely. I mean, we've all, look, a lot of these credits are relatively new, and if anybody's north of the border here, and I guess even south of the border, depending on who's in power, that these things are subject to change, and that can unfortunately happen overnight. And so we've always made it our mandate to make sure that this business model works independent of credits, right? Independent of grants or tax credits or what have you, because that's an external risk that we're not willing to stand in front of. So the model works. The energy as a service model, that is, works without any help due to the fact that the operating costs of the systems are much cheaper. Now, that said, if we can get the grants or if we can get incentives, all the better, and we can include that into the financial model. And the likely way that plays out usually, let's say that there's a reduction in the capital cost by way of a grant or an incentive. If that capital cost can come down, then that can reduce the operating cost over the term, because the renewable energy fee is fairly linear with the capital cost. Some of what that fee is returning. It's like paying a mortgage, right? If you've got buy a house for $300,000 as opposed to $500,000, your mortgage is going to be lower. It's a similar sort of concept. So insofar as we can bring down our capital costs and make use of those credits, the operating costs can come down. The renewable energy fee, I should say, can come down as well.
Great. Does Subterra work in or provide services in all provinces and territories in Canada, or what about the US states?
Yeah, so we're active across all provinces and states as well. Yeah.
Great. Can you confirm that under the 30-year financing approach, you are typically at a break even to 10% savings on operating costs?
Sorry, say it again. Can we?
So the question is, can you confirm that under the 30-year financing approach, you are typically at a break even to 10% savings on operating costs? I think that's project specific, right?
Yeah, I mean that's the target, and part of the reason we do the feasibility study is to confirm that. Once if they're in 99% of the cases, the costs will work, but if for whatever reason we get into a case where the overburden is 400 feet and the drilling is just going to be extremely expensive, there are cases where we said, hey guys, we just cannot make these numbers work. Unfortunately, we can't engage. And again, the reason we're so careful about that is that we're ultimately taking taking that financial risk, and this is a long-term investment. And if the costs are too high and tenants are unhappy, they're either not going to engage, or they're going to walk away, or it's not a very good situation. So we're very, very careful to make sure that is the case. And again, with the feasibility study done at the front, if we find that we cannot make the numbers work on the financial model, then we will not engage.
Great. So a question was asked, do you take the federal tax credit? And I would guess, to expand on that, does Subterra realize all of those incentives, or do you work with the ownership team to see which bucket that will fall?
Yeah, I'll say that one is a case by case. Reason being is that if you go and read the terms and conditions of all of the credits, et cetera, the credit needs to go back to effectively the owner, really simply put. So if we are the owner of the geothermal system, then we would be getting those credits. But again, some of that, what's considered the geothermal system, could be the HVAC side, so that can be considered the building credit, or the building side. Sometimes we will bring the building owner in as a partner. We've got a model that's considered a joint partnership, where we will basically JV with the building owner, and in that case, they could be the owner and receive all the credits. So it's that one's a fairly case by case basis, and we're fairly flexible in the way that we can structure those. But there is obviously rules that we've got to follow, and we can't bend the rules of the act, unfortunately.
Great. Just two more questions. So one, is the building HVAC system, the blue dotted line on one of the provided slides, included in the 30-year financing under a conversion to OpEx, or does this remain as CapEx to the building owner?
So this is a question, right? Who owns the stuff in blue, I think, is the question, right?
Right. Well, really, it's who's paying for it, right? So if it's part of the CapEx still as part of the property owner, and I think he's asking particularly as it's a retrofit, I assume, because he's saying conversion. Right. So
the short answer is yes, that is on the building to provide the capital for. The building, again, owns everything that's downstream of the heat exchanger. So all of the distribution system, all of the airside HVAC is owned by the building, and therefore has to be paid for by the building. There are cases here we've just had a little call out. If, for example, let's say you're down in a very hot state in the south, and you find that it's advantageous to add a fluid cooler because the load is imbalanced, and so the design wants to have a fluid cooler on it. In those sort of cases, we will also own that piece of equipment, because it works in tandem with the field. Effectively, it's backup for the field is the way to think about it. So in those cases, we can own those pieces as well. But the general sort of rule of thumb is that everything building side is owned by, paid for, both the CapEx and the OpEx, by the building side, by the building owner.
Great. Last question, because we are at time. How many buildings have you done, and when are you coming to New York?
So right now we've got, I think the number is 7 or 8 that are operational, and that's handed over, running, etc. There's probably about another dozen or so that are in kind of construction, and then another maybe dozen or so that are kind of in active development. And again, when we're starting to get involved with projects at zoning stage, there can be another year before they put a shovel in the ground, and then another 2 to 3 years before the building's done and turned on. So it's a very long cycle, and it's taken a while to sort of get all the projects through that stage. Happy to come to New York now. We've got the ability to go there and be there. We've not got an active system there yet, but we've looked at a number, and that's certainly something that we're going to be involved in. That's a state that's obviously very behind what we're doing here and what this whole group is doing.
Great. Well, that is our time for today. Thank you so much, Matt, for presenting this information.
Awesome.
As we mentioned early on in this presentation, everything is being recorded and will be uploaded to our YouTube channel. If you have any questions, please feel free to send them along. Matt to provide his contact information at the end of this, or you can send it to info@IGSHPA.org. Thank you so much for everyone who attended today, and we look forward to seeing you at the next event. Have a wonderful day.
Thanks so much.